So also in section 2.5, you are given some matrices and you're asked to find the inverse of the matrix if it exists. So problem 29, you're given this matrix 4, 2, 1, 2, and just for simplicity, I'm going to call that matrix A. The first thing we need to do in order to find the inverse of matrix A is to actually find the determinant of matrix A. So recall from the earlier video how to find the determinant of this matrix. Since it's 2 by 2, we simply take the product of the downward diagonal numbers, so 4 times 2, minus the product of the upward diagonal numbers, so 2 times 1. So then in this case we've got 8 minus 2, which is 6. So that number is very important for a couple of reasons. First of all, if the determinant had come out to be 0, then there is no inverse matrix. So this number has to be something other than 0 in order for the matrix to have an inverse. Okay, we will also need that in constructing the inverse matrix. So the inverse matrix, and they use this funny notation that looks like a to the negative 1. And if you were to read that, you would read it as inverse A, or A inverse. We can calculate A inverse by taking 1 over the determinant that we just calculated, so 1 over 6, times a matrix that is a modified looking version of the original matrix. Here's how we modify it. What we do is we take our downward diagonal and we switch those two entries. So the 2 will go in the upper left and the 4 will go in the lower right. And then on our upward diagonal, what we do is we negate the numbers, which means we just change their sign. So now that's a negative 2 in the upper right and a negative 1 in the lower left. Now, in some textbooks they expect you to distribute this 1/6 into all of the entries of the matrix, and other textbooks allow you to leave your answer in this form. So this might be the answer that they're looking for, or if they want you to multiply it through, then 2/6 is the same as 1/3, negative 2/6 the same as negative 1/3, you'd have negative 1/6, and then 4/6 is the same as 2/3. So you're just doing scalar multiplication at that point.